Star is being changed into a stellar taffy and a cosmic doughnut by a hungry black hole. Imagine a cosmic feast unlike any other, where a hungry black hole indulges its appetite in sweet tooth. Astronomers have made a remarkable discovery of an enormous black hole transforming a hapless star into a stellar taffy and a cosmic doughnut. Join us as we dive into this captivating celestial event. An enormous black hole with an appetite and a sweet tooth has been found by astronomers. Before devouring this cosmic sweet, the black hole is tearing apart a poor star, stretching it like taffy, and forming the leftovers into a stellar doughnut the size of the solar system. The violent incident, known as a tidal disruption event, TDE, was originally discovered by the All-Sky Automated Survey for Supernovae, ASAS-SN or ASAS-SN, by a burst of high-energy radiation. The feast is happening 300 million light-years distant, at the galaxy's nucleus. Astronomers used the Hubble Space Telescope to examine the picture near the galaxy ESO 583 G04 center in ultraviolet light after making more observations of the outburst. The group of astronomers was able to reconstruct the image using light from the dying star, despite Hubble being too far from this TDE, known as at 2022 DSB, to see the fate of the star as it developed. The star's spectra showed how it was shattered by the black hole, stretched out like taffy, and fed into the black hole. A donut-shaped torus of star material and superheated gas surrounds the cosmic monster as a result of the TDE process. And while most of this material will eventually fall into the black hole, some will escape into space. The messy eaters are black holes. Around 100 of these cataclysmic encounters between black holes and stars have so far been observed by telescopes, including Hubble. Stars that wander too close to black holes are destroyed by the tidal forces produced by the black hole's massive gravitational pull. Since most TDE observations are conducted in X-ray light, what makes the observation of a 2022 DSB unique is that it was made in ultraviolet light. The Harvard-Smithsonian Center for Astrophysics' Emily Engelthaler stated in a statement that there are still very few tidal events that are observed in ultraviolet light given the observing time. This is particularly bad because the UV spectrum can provide a lot of useful information. The team that used ultraviolet spectroscopy to observe TDE at 2022 DSB was able to keep track of it for a longer time than normal, from the start through later stages of the feeding, or accretion. These events are typically challenging to observe. Perhaps a few observations are made when the disturbance first starts, when it is quite bright. Our program is unique in that it is created to examine a few tidal events over the course of a year to determine what occurs, according to CFA researcher Peter Maxim. We detected this early enough to witness it during these really active periods of black hole accretion. The pace of accretion decreased over time, eventually becoming a trickle. TDEs have demonstrated to astronomers that black holes are messy eaters, which implies that some of the material left over after the poor stars are obliterated in these feeding events will be ejected out into space, possibly as jets of matter flying at extraordinary velocities close to that of light. It's the same with this TDE. According to the team's observations, a star wind is blowing toward Earth at a speed of around 20 million miles per hour, 32.2 million kilometers per hour, or about 3% the speed of light. Astronomers can learn more about the eating black hole from ultraviolet spectroscopy and measurements of the changes occurring in the remnants of the star destroyed in the TDE at 2022 DSB over the course of days to months. We're happy that we can learn more about what the debris is doing. The tidal event can reveal a great deal about a black hole, according to Engelthaler. We're happy that we can learn more about what the debris is doing. We can learn a lot about a black hole from the tidal event. The researchers examined the Hubble spectroscopic data from a 2022 DSB and concluded that it is emanating from a very bright, hot, donut-shaped region of gas that was previously the star's raw material. Additionally, they were able to determine that the size of the gas torus surrounding the black hole is comparable to our solar system. Maxim claims that the observations are made from a location near the donut's edge. Maxim said, "We genuinely are still trying to process the tragedy. The star is torn apart, and the resulting debris is entering the black hole. Thus, there are models that give you the impression that you understand what is happening, and then there is what you actually observe. The intersection of the known and unknown is an interesting area for scientists to be. The team's findings were presented at the American Astronomical Society's 241st conference on January 12. We have reached the end of this epic cosmic event. A star, transformed into stellar taffy and a cosmic doughnut by a ravenous black hole. We thank you for joining us on this extraordinary journey. We hope the enchantment of this celestial spectacle has captivated you as well. Witnessing the insatiable hunger and cosmic sweet tooth of black holes. Don't forget to follow us as we continue to explore the interstellar flavors.